Let's find the antiderivative of let's say 4x plus 7. And then we're going to do that, this antiderivative of this function 4x plus 7 with respect to x. So how do we find the antiderivative of this function 4x plus 7? As there is a rule here that the entire derivative is actually it satisfies the linearity property. What does that mean is, let's say if we want to integrate, if we have let's say a couple of terms on an expression or the function or something like that, we can actually integrate term by term. So we can just figure out the entire derivative of 4x. We can just find the entire derivative of 7 and then just add or subtract whatever we have over here. Okay, so we can do that. So to figure out the entire derivative of 4x plus 7, we just try to figure out the entire derivative of first 4x. Okay, so let's find that, and then we're going to do that with respect to x, and then we figure out the entire derivative of this 7, that next term, right, with respect to x, and just add here because we have that add, right? So we just want to do that. But then what is the entire derivative of 4 times x? If you look into here, that 4 is a constant, multiply by x, right? So if you have a constant, multiply by x, like on the derivative, or that the constant multiple rule holds in the entire derivative, which means just figure out the entire derivative of x, whatever is that, and multiply by 4. We can do that. Okay, so if that is the case, so you can just take 4 out, right? So from the integral sign, let's say, and just find the entire derivative of x, and then what would that be? So 4 times, how do we figure out the entire derivative of x? Entire derivative of x, right? So x is kind of what, something like a power function. So there is a rule which is called what, power rule, let's say, of the entire derivative, which is if you have x to the power n, right, its entire derivative of that would be whatever is in the power, just add 1 in the power. So let's say we have n, so we add 1 in the power, and then so now the new power is n plus 1, and multiply by the reciprocal of that new power. So this should be the formula, okay, to find the entire derivative of the power function like x to the power n. But this formula works for all real number actually except -1. But on our case, you can see here we have x, right, and then we have x to the power n. So that power in the power, if we have nothing, we can say 1, right? So if that is the case, we can definitely use this power rule. So by applying the power rule, the entire derivative of x should be then x to the power, so 1 in the power, so add 1, so 1 plus 1 will be 2, and multiply by the reciprocal of that. So 1/2 x square is the entire derivative of x. So and then we multiply by 4 to get the entire derivative of 4x. So that's the entire derivative of the first term. Okay, in the same way, let's try to find the entire derivative of the second term. We have just 7 here, which is just the constant, and then there is a constant rule, right? So the constant rule of the entire derivative is, if you just have any constant, then its entire derivative is that constant multiplied by x plus c. I forget the entire derivative. To write down the general entire derivative, we need to have the arbitrary constant, integration constant, right? But that's just the to give the family of the entire derivative. Anyway, but now we have the entire derivative. The rule for the constant rule to find the entire derivative of this 7. So let's use that. So this should be then 7 times what, x, right? And then so we definitely find the entire derivative of 4x and then 7, but then we need to have, look like by the formula, we need to have 2c, but those are just the arbitrary integration constant. When you add those arbitrary integration constant, both of those, you may get another arbitrary, right? So you can just write down one single arbitrary constant, it's fine. But then this should be the family of the entire derivative of 4x plus 7. We can further simplify. 4 divided by 2 is 2, so we have then 2x squared plus 7x plus c is the entire derivative of 4x plus 7. So in the same way, we can figure out the entire derivative of any other, let's say this kind of function. Okay, so for example, let's say if you have 2x minus 3. What should be the antiderivative of this one? So we just need to find the antiderivative of 2x, which is 2 times antiderivative of x, like in the previous case. By applying the power rule, we have x to the power 1 plus 1, so 2 multiplied by the reciprocal of this new power, so 1 half x square is the antiderivative of x, multiply by 2, right? And then minus antiderivative of 3 is 3 times x, right? So plus c, so we get x square minus 3x plus c is the antiderivative of 2x minus 3. Alright, I hope that by looking into these two examples, you get an idea how to find the antiderivative of this type of function.